Hello! In this video we're going to be going through lowest common ancestor of a binary tree 3, which is LeetCode problem 1650. This problem is marked as a medium and it's fairly new and fairly popular, but it is high on the frequency list. Given two nodes of a binary tree P and Q, return their lowest common ancestor, LCA. Each node will have a reference to its parent node. The definition for node is below. Yada yada. According to the definition of LCA on Wikipedia, which we know Wikipedia is always right, the lowest common ancestor of two nodes P and Q in a tree is the lowest node that has both P and Q as descendants. And we also allow a descendant to be a descendant of itself. Allow me to introduce myself to myself. Alright, root. Just because I figured out how to read these. So 3, 5, 1, 6, 2, 0, 8. Then null, null, because the 6 doesn't have a left or right child. Then we have 7 and 4, and apparently we don't care about the children of the 0 and the 8. So if P is 5 and Q is 1, then the parent of these is going to be 3. So down here we have 5 and 4. The parent is going to be 5 because 5 is, it's in the same branch, and 5 is the parent of itself as well as 4. Alright, so how are we going to do this? Okay, so this is a very straightforward problem. We're just going to take node P and keep looping through it, assigning it to its parent until it gets to the top, and then it's null, and then we'll assign it to Q, and then keep looping, and so we'll keep looping through these until they equal each other. And I'll show you what I mean here. So node P1 is just going to be equal to P. And then node P2 is going to be equal to Q. Alright, so while these don't equal each other, we're going to do the null cosyllating operator here. So P1 is going to be equal to the result of this expression. So if P1 equals null, then we're going to assign it to Q. But if it's not null, then we'll just assign it to its parent. And then we'll do the same thing with P2. So P2 equals null. We'll assign that to P. Otherwise, we'll assign it to P2 parent. And then those will keep going through until they equal each other, and then we'll just return P1. We can return P1 or P2, it doesn't matter, because they equal each other. So let's debug this and see what we get. Okay, for this example, I just used example 1. And so P is going to be 5, Q is going to be 1. So we'll just go through here. You can see P1 is 5, P2 is 1. So while P1 is not equal to P2, which is true, so P1 is not null, so we're going to assign P1 to its parent, which its parent is 3. 3. And then P2 is not null, so we're going to assign P2 to the parent, which is also 3. So that's, boom, easy peasy. Return P1, which is 3. And that's all she wrote. Alright, let's try running this, see if I did it right. Looks like I did. Submit it. Ooh, faster than 28 and 22. Let's try again. Whoa, we got 65 that time. I'll take it. Now I'll do the time complexity. Time complexity is O of n. We're just looping through the binary tree so we don't increase or decrease the time needed based on the inputs. Is O of 1. We're not using more space, we're just looping through the tree. And that is it. So let me know if you have questions. Thanks for watching, and we'll see you next time.